In this video, we're going to talk about finding zeros of factored polynomials. Okay, so finding zeros basically means that we're going to take this function and set it equal to 0 and figure out what the solutions are. Okay, so we'll have negative 5x times x minus 3 times x squared minus 25, and we'll set that equal to 0. Now, the one thing that we want to do on this is take care of this x squared minus 25, and that's going to be a difference of squares. Recall that if you have a squared minus b squared, that's the same thing as a plus b times a minus b. Okay, so this is my squared term here, x squared, and this is 5 squared. Okay, so this will factor into x plus 5 and x minus 5. Okay, so that's because the square root of 25 is 5. So this becomes negative 5x times x minus 3 times x plus 5 times x minus 5. And that's all equal to 0. Now we can use a zero product property to set each individual term equal to 0. And if there's any repeating terms, you don't need to write them twice. Okay, so we get on this one, we divide by negative 5 on both sides. Okay, 0 divided by negative 5 is still 0, so x equals 0 is our solution on that. Add 3 to both sides, so you get x equals 3. Subtract 5, you get x is equal to negative 5. And add 5, and you get x is equal to positive 5. And those are your 4 solutions on this problem. Okay, on this problem, we're also asked to find the zeros, which means we're going to set this thing equal to 0. And it looks like it's already factored for us. Now, we do have some exponents going on here. Okay, so recall that if you have an exponent, like if you have x to the 2 power, that's the same thing as x times x. Okay, so if we have x plus 5 to the 3 power, that means it's x plus 5 times x plus 5 times x plus 5. But all 3 of those would give us the same solution, so we don't need to write them all 3 times. We might need to state in a certain situation that it has multiplicity 3. The solution of x equals negative 5 comes up 3 times, but we don't need to write the solution 3 different times. Okay, so let's set this equal to 0. Okay, and we don't need to set the negative 3 equal to 0 because we can divide the negative 3 on both sides. In fact, I can do that here. If we divide the negative 3, it cancels here, and you get still 0 on the other side. So you get x plus 5 cubed times x minus 4 squared equals 0. Now, if you set those terms equal to 0, okay, to get rid of the cube, we take a cube root. Okay, but the cube root of 0 is still 0, so it ends up just being x plus 5 equals 0, which gives you x is equal to negative 5 as your first solution. Okay, and the same thing on this, we take the square root to get rid of a square, but the square root of 0 is still 0, so you really just get x minus 4 equals 0, which is x is equal to 4. Now later on down the road, you might need to say that this was a solution of x equals negative 5 with multiplicity 3, because it came up 3 times. It was x plus 5, x plus 5, x plus 5, which means the cube. And this one would be multiplicity 2. Okay, in this problem we're going to again find the zeros, which means what are the x values that make this thing equal to 0. So we set it equal to 0. So we have 5 times x squared plus 4 times x minus 16 times x plus 7 squared all equals 0. Okay, so we know that this one can be solved and this one can be solved. Does this one need to be factored or not, or what do we do with this? So we'll take a look at that one separately over here. So x squared plus 4 equals 0, and we can go ahead and get these other solutions real quick right here. Okay, so we add the 16, we get x is equal to 16. That's one of our solutions. Take the square root like we did on the previous problem. Okay, square root of both sides. So that's x plus 7 equal to 0. So x is equal to negative 7. That's 2 of our solutions. Okay, now on this one, let's see if we can get x by itself. So we move the 4 over, we get x squared is equal to negative 4. Okay, so stop and think about this for a minute. Is it possible to square a number and get a negative answer? Like if I squared negative 2, negative 2 times negative 2 is positive 4, not negative 4. Okay, so this one doesn't have any real solutions. Now, if you were asked to find any complex solutions, you could figure this out. Okay, so depending on if it wants you to find real solutions or complex solutions, this particular problem, it only asked us to find real solutions. Okay, so this is going to be no solutions at all. Okay, on that. So your other two solutions are the only ones that would count. Now, real quick, if this was asking for complex solutions, you could go ahead and take the square root of both sides. Put a little plus or minus there. So x is equal to the plus or minus the square root of negative 4. And if you know about the I in the complex number, you can take out an I and make this a positive square root of 4. So x is equal to plus or minus I positive square root of 4, which is, excuse me, x is equal to plus or minus 2i. Okay, so if you're asked to find complex solutions, this would be two of your solutions. But in this particular problem, it asks us to only find real solutions. So this isn't going to be a solution that we write down. Okay.